Yes, welcome to Lesson 4 in the Ratios and Proportional Relationships section. This is Module 1 we're working in, and today we're going to talk further about identifying proportional and non-proportional relationships in tables. Here's our first example. Which team will win the race? You have decided to run in a long-distance race. There are two teams that you can join. Team A runs at a constant rate of 2.5 miles per hour. Team B runs 4 miles the first hour and then 2 miles per hour after that. Your task is to create a table for each team showing the distances that would be run for the times of 1, 2, 3, 4, 5, and 6 hours. Okay, and you're going to go ahead and do that, and following these tables here are some questions, and those are questions A through H. So I want you to go ahead and pause the video and take about 10-15 minutes, whatever you need, to complete these questions to the best of your ability, and come on back and we will look at them together. Okay, so see you soon. Okay, welcome back. Let's go ahead and take a look at what you did and fill in our table. Okay, so here we go. There's our table here. Let's go ahead and get a different view so we could actually work with it a little bit easier. Okay, so here we go. So let's go ahead. We know that Team A runs at that constant rate, and that word constant should have been a real clue there. Okay, so let's go ahead and do this. It goes up to 6 hours at a constant rate. So after the first hour was 2.5 miles, and then 5 miles, 7.5 miles, 10 miles, 12.5, and 15 miles. Okay, so you can see it's constant, and it is proportional. So you can see that we could just answer this question right here. It was Team A has a distance that is proportional to time throughout. Okay, so throughout, every time you are multiplying time by 2.5 to get the distance in miles. Okay, now Team B, a little bit different. They came out running 4 miles an hour right from the start, but then their pace slowed down to 2 miles per hour thereafter. So that means we have 6, 8, 10, 12, and 14. Okay, so we can see that it's not proportional, and that's this question B right here. It's not proportional because in the first hour we have a multiplier of 4. Okay, but in the second hour, after 2 hours, we have a multiplier of 3. And then after 3 hours, we have a multiplier of 2 point something or other, and 2 point something, 2.3 or thereabouts. So you can see that it changes. Okay, so it's not proportional throughout. Alrighty. So now C asks you, if the race were 2.5 miles long, which team would win? And we need to go back and take a look at our tables. And you could see if it were 2.5 miles, and that would have been right here, you can see that for Team A, 2.5 miles takes them 1 hour. But as you can see, B has already gone 4 miles in that hour, so you can see that 2.5 miles is going to be less than an hour. So that would be Team B, of course. Okay, Team B would win. Again, if the race were 3.5 miles long, we can look back there. 3.5 miles is the same situation. Okay, it's still less than, you can see it's still less than 1 hour because they went 4 miles in an hour. So 3.5 miles, they're going to do that more quickly. And again, same idea here. These guys they've only gone 2.5 miles in an hour, so it's going to be more than an hour for them. Okay, so this would also be Team B. Now the next question I think must have been an error initially on the part of these Engaged New York folks who put this together, because it asks the question if who would win in 4.5 miles, and gosh, it's been pretty pretty obvious who's been winning the entire time. So if we looked 4.5 miles, I think that might have meant 4.5 hours who went further distance. But anyway, so if we do look at that question, 4.5 miles, pretty obvious to see still that it's going to be Team B. Team B already has gone 4 miles in 1 hour. Okay, these guys, it took 2 hours to get to. It took 2 hours to get 5 miles. So you can see it's pretty obvious that another half a mile here, and in Team B, that's only going to take them another hour to get. Well, actually another 2 mile, another half a mile. Oh, it's going to take like a quarter of an hour. So it's not going to take very much time at all. Whereas here with A, we're still be behind. A does indeed catch up at some point, but not quite yet. So again, this was B, and then this would also be B. Okay. Now, for what length race would it be better to be on Team B than Team A? And we can see a 4-mile race is good. Okay, a 6-mile race, 8-mile race. Okay, these are all good. Team B is going to win all of these here. Okay, is going to win all of these races right here. Okay, because they have a faster pace still at that point. Okay. If we look at the next question, next question does indeed asks us now here again. These are B, 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 and again everything, everything up to 10 miles. Okay, everything up to 10 miles, because we take a look right here, everything up to 10 miles. 10 miles is where things even up, and you can see right there at 10 miles, they both are averaging 2.5 miles per hour, and that would be a 10-mile race right there. Would have been a dead heat. Okay. All right, I'm not sure why I keep losing these letters, but I have been. Okay, let's see. E asks us, using this relationship, if the members on the team ran for 10 hours, how far would each member run on each team? Okay, so now we need to solve for 10 hours. Okay, so we can go back and refer to our table right here. Let's extend our table down. Okay, to 10 hours. And again, for Team A, really easy, because all we have to do actually is we don't really even do any of this, but we just need to apply our rate of 2.5 miles and per hour, and we know that we will have 25 miles. They will have gone 25 miles. Now, to extend this forward, there is no formula for Team B that we can apply, because the rate continually changes. It continually changes. All right. So we have 16, 18, 20, and 22, and you can see now that Team B is falling behind. Again, we talked about the tie being right at 10 miles. Anything before that, any race shorter than that, you'd want to be on Team B, but everything thereafter, you'd want to be on Team A, because they continue at that 2.5 mile per hour pace, whereas Team B is now going just 2 miles per hour. Okay. Okay, so let's take a look at our next question here, question E. I think it was E. Take a look here. We have, actually no, F. Will there always be a winning team, no matter what the length of the course? Why or why not? And again, we've answered that one already. There would be, not at 10 miles. We would not have just not at 10 miles. Everywhere else, there would be a winning team, but at 10 miles, we are a tie, with both teams averaging a pace of 2.5 miles per hour. Okay, so if the race is 12 miles long, which team should you choose to be on if you wish to win? If you wish to win. And again, why would you choose this team? Well, because they would win if you want to win. But if we go back and take a look, we can see we decided that anything, I lost that one, lost that slide. At 10 miles, it's a tie, no winner. Any distance race before that, you'd want to be on B, and any distance race after that, you'd want to be on A. Okay, and then finally, the last question there asks us how much sooner would Team A finish than Team B. So we could let's go ahead and read that question as it's written here. I've made such a mess out of this. So sorry. There's H. How much sooner would you finish on that team, which is Team A, compared to the other team? We have to go back and look at our chart. And the information we have already for us is we have Team B's 12-mile time. Okay, Team B finishes 12 miles in 5 hours. Okay. Now Team A, we know finishes here between 4 and 5 hours. So we know that it's faster. But if we want to go ahead and figure it out exactly, okay, we could go ahead and apply our formula, because we know that our distance, okay, equals our time times 2.5, which is our rate. Okay, so the distance, we have the distance, we're being given the distance in this problem of 12 miles. So we know 12 miles is going to equal t times 2.5. So all we need to do is we need to do some division, and we are going to go ahead therefore and we are going to divide 12 by 2.5. Okay, and if we go ahead and do that, we are going to figure out that we are going to have, that is 4, and again you guys, 4.8. Okay, so 4.8 hours for Team A. Now the way 4.8 and 5 compare, okay, the idea is we want to turn this into minutes. So we know that it is 0.2 hours more, or 2/10 hours less. Okay, so 2/10 of an hour. If we take a tenth of an hour, equals 6 minutes. Okay, so what we're doing here is we're multiplying 2/10 times 60. Okay, and if we did that like that, we know how to multiply our fractions. That would be 120 over 10, which equals 12 minutes. Okay, and also we know that each tenth of a minute is 6 minutes, and if we had 2 of those tenths, we would have 12 minutes. Okay, so yeah, the answer to that question therefore would be how much sooner you would finish 12 minutes sooner. Okay, all right, so the rest is for you to do. Your problem set, your exit ticket, do those and come back soon to do lesson 5. Thanks so much for your time.